Live from around the world, it's 3.14 News Tonight, starring Shalandria Lee, Dominique Templeton, and Jessica Bethea.
Good evening, everyone, and thank you for joining us on 3.14 News Tonight. Tonight, we will be visiting with experts about the physical properties of ionic compounds, covalent compounds, and metals, since it has been recently discovered that Americans lack a clear understanding of these concepts. Now, let's take a look at the shocking evidence.
So, what do you know about covalent compounds?
Absolutely nothing.
Well, do you know what an ionic compound is?
No, not off the top of my head.
Sir, if I told you that dihydrogen monoxide could kill you, would you be scared?
Yeah.
Sounds pretty scary, doesn't it?
And there you have it. It's a shame, isn't it? Now, let's join Professor Virginia Tate for a closer look at ionic compounds.
It's easy, like taking candy from a baby.
Thank you, Shalandria. What Americans don't know is that ionic compounds are actually very simple things to understand. In ionic bonds, an anion, which is usually a nonmetal, takes away electrons from a cation, which is usually a metal, just as a bully takes away candy from a baby. At room temperature, these compounds usually exist as solid crystals. It takes very high temperatures, normally above 300 degrees Celsius, in order to melt these compounds. Also, they can conduct electric current when they have been dissolved in water. Lastly, ionic compounds are very brittle due to their crystalline structure. Thank you, Professor. Now let's turn to Professor Jessica Bethea for the inside scoop on covalent compounds, their physical properties, and covalent bonding.
Thank you, Shalandria. Looks like America needs to learn something about covalent compounds. See that? You might as well refer to that as two nonmetals fighting for that last electron that they need in order to become stabilized. Their valence electron shells need to be filled in order to fulfill the octet rule. But they can't. Unlike ionic compounds, covalent compounds have to share an electron because one just cannot take it from the other. Some properties which are unique to covalent compounds include low melting and boiling points, poor conductors of electricity, softness, and insolubility of water. Let's test some of these properties, shall we? Yes, certainly much slipperier than water.
Thank you, Professor. We are running short on time, so now let's turn our attention to Professor Chili Lee, who has information on the physical properties of metals and metallic bonding. Thank you, Shalandria. We encounter metals every day of our lives. Metals are very good conductors of electricity due to their metallic bonding. Also, metals are very malleable, and they can be hammered and forced into different shapes without breaking. Metals are ductile, which means that they can be drawn into wires. Lastly, metals have great luster, which makes them appear shiny. Back to you, Shalandria. Thank you. We'll be back after a short commercial break. You were watching 3.14 News Tonight. Stay tuned. Have you ever pulled into a Wendy's, asked for some french fries, and got some nasty, bland pieces of potato in return? Well, that's because they were lacking the ionic compound, salt. Salt should be your #1 priority because it makes your food taste so much better. It conducts electricity when dissolved in water. They're solids at room temperature. They're extremely brittle, unlike metals. And they form very pretty crystalline structures. So, what are you waiting for? Call 1-800-333-SALT and get your pack of delicious salt today. Our oceans are home to many different animals. However, pollution has greatly impacted all of the animals living in our seas. With your help, families of fish such as this one can be held together in their watery environment, just as a metal is held together by the attractions between their electrons and the metal cations. Please, call today. Welcome back to 3.14 News Tonight. Now, let's join Professor Jessica Batha for an inside look on the physical properties and chemical characteristics of polar covalent and non-polar covalent compounds.
As far as covalent compounds go, there are two types of them, polar covalent and non-polar covalent. In non-polar bonding, electrons are shared equally. In polar bonding, electrons are shared unequally, usually because one atom has a stronger electronegativity than the other. But how can we tell which one is polar covalent and which one is non-polar covalent? Let's compare two different substances and find out! One way to check whether or not a covalent compound is polar or nonpolar is to check its solubility in water. If the covalent compound is polar, then it will ionize and dissolve in the water. As you can see, the sucrose is already starting to do. As for the oleocanthal, which is the most active ingredient in olive oil, it will not dissolve, as it is indeed a nonpolar covalent compound. So there you have it. Shalandria, back to you.
Thank you, ladies. Well, this wraps it up for us tonight. I hope that everyone has gained a clearer understanding of these concepts. Good night, and thank you for joining us on 3.14 News Tonight.
This has been 3.14 News Tonight, coming at you from around the world. Thanks for tuning in. Have a great night.